All right, guys, here we go. We're going to get into continental glaciers now, move away from alpine. Here are the objectives. First, we'll talk about why we're talking about continental glaciers. We'll get into erosional, the difference between erosional and depositional features. And then lastly, we're going to talk about all these guys here, these 9 features of continental glaciers. So let's go ahead and get into it. As always, if you have any questions, please feel free to send me an email message. All right, let's take some notes. All right, so why are we talking about glaciers anyway? Why are we talking about continental glaciers? Take a look at this diagram of Illinois here. It shows 3 different periods of glaciation over the last few tens of thousands of years. However, what it's showing is that our entire state was once covered by a continental glacier. You know, when you drive across Illinois or drive downstate, you're going to notice that our state's pretty flat. But if you ever make it up here into Galena, or if you ever go out cruise all the way down here to around Cairo, Illinois, or southern Illinois, you're going to notice that there's a lot more topography or a lot more definition to the shape of the land in northern and southern Illinois. Why? Because glaciers didn't hit that part of our state for various reasons why, but everything else is flat because it got covered by a glacier. So when we talk about why continental glaciers are important, we only need to look at our own landscape to understand the relevance of why we're talking about this. But in addition, it's also glaciation and the erosion that it did that helped make our state soil so fertile, which makes us an incredible farm-producing state. So there's absolute relevance when we start talking about continental glaciers and why we're talking about them. All right, so here we go. Let's get into some of the notes. Make sure you take good detailed notes. All right, so let's go ahead and take a look at this top picture over here. I'm talking about the rock with the 3 people standing on it. You know what's interesting about this is that rock was carried in by a glacier. It's called an erratic. E-R-R-A-T-I-C. E-R-R-A-T-I-C. And an erratic is simply any individual large rock that gets deposited by a glacier after it melts. So any single large rock that gets deposited by a glacier after it melts, and that's an erratic. Now, how do I know it's an erratic? Let's go ahead and zoom in down on this rock over here, which is from the same area. Take a look at the surface here. Notice that it looks all kind of smooth and shiny. There's a little camera lens here just for scale so you can see how big this is. But notice that the sun's reflecting really shiny off the top of this, and there's all these scratches here. That shininess is actually very characteristic of rocks that got carried by a glacier, and it got shiny because of abrasion. That's called glacial polish. Glacial polish. And that's when a rock gets smoothed over by a glacier due to abrasion as it's moving within the glacier. But then you also see these scratches that all have a very uniform motion to them, that are a uniform direction to them. Those are called striations. S-T-R-I-A-T-I-O-N-S. Striations. And a striation is a groove that has been eroded into the rock, or scratches that's been eroded into the rock as it's been polished because of abrasion while it's moving with the glacier. All right, so let's go ahead and zoom out and zoom in on this picture over here on the left. Now, if you notice, what we have is we have the glacier here, and the glacier is retreating, which means it's melting. Just a little bit of vocab for us. A retreating glacier is a melting glacier. And here's the terminus at this point at A. Remember, the terminus is the end, and then we know it's retreating because the terminus is moved up, and then we get the terminus moving further up over here in situation C. Let's jump back up to A. Notice that we have these very large rocks that are being carried by the glacier. And then after the glacier melts, those large rocks get deposited on the ground. That's what an erratic is. It's a large rock that gets transported by a glacier from somewhere else. All right, let's go ahead and stay on this picture here and talk about something else. We're going to talk about something called glacial drift. G-L-A-C-I-A-L, drift. Now, an erratic is any single individual large rock that gets carried by a glacier from far away, from somewhere else. Glacial drift is all the rest of the sediment that gets carried by a glacier. It's material that's drifting from one place to another as it gets carried by a glacier. So I'm drawing in all this glacial drift here. What's the difference between an erratic and glacial drift? Glacial drift is more of a general term to describe all the rocks that are carried by a glacier as it's moving, and an erratic is a single large individual rock that gets deposited when the glacier melts. All right, now as we know, eventually this glacier here is going to melt. And what's going to happen is you're going to get this pile of glacial drift that gets deposited all over the ground here. And that's called till. T-I-L-L. Till. The difference. Glacial drift is the stuff that gets carried in the glacier, and till is the stuff that gets deposited after the glacier melts. So till is deposited glacial sediment, glacial drift is stuff being carried by the glacier, and an erratic is a single large boulder carried in by a glacier from somewhere else far away. All right, let's take a look at this plain here, this flat field here formed by continental glaciers. And if we notice, there's a few things here we could take a look at. We have a whole bunch of deposited sediment here. Now, what's key to mention here about this sediment is that it's all sorted. And the reason why that's important is it distinguishes it from till. So this stuff is sorted. Now, if you think back to what sorts sediment or what organizes it by size, you'll probably think about rivers, because that's what we learned sort sediments. It's one of the agents that will go ahead and sort sediments, or one of the things that will sort sediments as a river is flowing. And we definitely have a meltwater channel here. We have some rivers flowing here from the melting glacier. You can maybe see some remnants here of an old meltwater channel. But what we have here is we have this sorted sediment, this sorted glacial deposits. And this is called an outwash plain. An outwash, O-U-T-W-A-S-H-P-L-A-I-N. An outwash plain is a field of sorted sediment. Now, outwash itself is just the sediment that's sorted, and an outwash plain is a field of the stuff. It's kind of like till. Till is unsorted sediment carried by a glacier, and a moraine is a pile of unsorted sediment. The only thing that's different between outwash and till is one is sorted, one's not sorted. And the only difference between a moraine and an outwash plain is one's more of a hill of unsorted sediment, that's a moraine, and this is a field of sorted stuff. That's what an outwash plain is. Here we have a meltwater channel. And this is a glacial meltwater. This is the stuff that's actually doing the sorting. And here we have a stick. All right, for the last 12 years or so, I've passed this lake here on Lake Cook Road around Milwaukee or so. And what I learned is that this is a glacial kettle. And what that is a big chunk of ice buried itself into an outwash plain, eventually melted and left the lake behind. In fact, this is exactly how Lake Michigan formed and the rest of the Great Lakes. A big chunk of ice buries itself into a field of glacial outwash. Eventually that ice melts, and if there's enough water to be above the water table, you'll get a kettle lake. So here in situation A, here we have the ice getting embedded into the outwash, gets buried a little bit, and it gets insulated in there, it hangs around for a while. Eventually it's going to go ahead and melt, and if it's above the water table, you'll get a kettle lake. If it's below, you'll get a dry kettle hole. But that may, with recharge and infiltration, fill right back up. And that's what a kettle is. All right, guys, 3 more things to get into real quick. First of all, you'll notice that we have, as a nice little review, you'll notice that we have a terminal moraine, which is the furthest moraine that glacier made. Remember, a moraine is unsorted sediment. Over here we have an outwash plain, and the outwash plain would be made of sorted sediment. We have, let's see, a meltwater channel hanging out over here. Here's our glacier that's receding, so it's melting a lot. All right, now we have 3 more depositional things to get into here. We have something called a kame, K-A-M-E, something called an esker, and something called a drumlin. What's the difference? They're all depositional features. All 3 are depositional. The only difference is shape. A kame is a mound. is a mound. So here's the ground, and a came is a mound of sorted sediment. An esker, here's the ground, is a long winding ridge of sediment. Similar to a moraine, but this is all material that piled up in the meltwater channel of a receding glacier. That's an esker. It's a long winding ridge that gets deposited in the meltwater channel of a receding glacier. So again, the meltwater is a key factor in the formation of an esker. And then lastly, we have something called a drumlin. D-R-U-M-L-I-N. Drumlin. You see a lot of these in Wisconsin. And a drumlin is like a teardrop shape, or kind of like a whale-shaped thing. It's a teardrop shape of sediment. So here we have a rounded mound, and this is a came. And here we have an esker, which is a long winding ridge that forms in the meltwater channel of a glacier. And here we have a drumlin. And a drumlin is a teardrop shape deposit of glacier material that you find on the outwash plains of glaciers. Alright guys, that's going to do it for us. We talked about the importance of why we study continental glaciers. Talked about the difference between erosional and depositional features. Erosional means that you're breaking something down. Depositional means that you take that broken up sediment and it settles down and piles up somewhere. We talked about all these continental glacial features, all 9 of them. Make sure you got some really good notes on all of these guys. I didn't put up the pop-ups. This was an exercise in listening and making sure you got the notes down that I was talking about. Again, if you have any questions, please feel free to see me in class, or you can send me an email message. Have a good night.